Okay, so, hello everyone. I want to mostly just go over very quickly double angle identities. Um, so basically, um, let's see here. So we know that obviously for sine of 2 theta, and I'm gonna go ahead and, you know, I did post a video or a short video on how to, do this problem, but I'm gonna, it's better, I think, to explain it in more detail um, on, uh, you know, as of right now, since I feel like I can explain it better. Um, so, obviously, this is the problem. It says find sine of 2 theta given tan theta equals negative 3/4. Oh, and by the way, guys, I hope everybody had a happy Thanksgiving. Um, and yeah, hopefully everyone ate a lot of turkey and, had a wonderful Thanksgiving. So happy Thanksgiving, everybody, or late Thanksgiving. Um, so basically, we need to find sine of 2 theta given tan theta equals negative 3/4, right? And so for this one, and let me actually give me 1 second. Sorry, everybody, give me 1 second. Okay, um, so this was the problem that I was looking at, and so the first thing that I want to emphasize on here is that so okay, so tan theta we know is opposite over adjacent, and this is the kind of the diagram for how to, where the opposite side is, the adjacent side, the hypotenuse, etc., right? And we know that tan theta is negative 3/4, so that's why on here I put negative 3 over here because that's the opposite side, and 4 right here because that's the adjacent side, right? Now, what I did was I solved for the hypotenuse because that will become useful later on. So we solved for the hypotenuse, we got that it was 5, right? The hypotenuse is 5, so the longest side of the triangle is 5, right? So then I redrew it here. I said that this is, these are all the sides of the triangle, and, you know, and so then I said, well, you know, then I said, well, what's cosine theta? And also, you know, yeah, like what's cosine theta and what's sine theta as well, right? Because we need those. The reason why I solved for sine theta and cosine theta, or I, you know, looked for those on the right triangle, was because sine theta, so over here, sine of 2 theta is defined as 2 times sine theta times cosine theta. So that's why we need to find sine theta and cosine theta so that we can figure out what sine of 2 theta is, because we have to multiply those two things in this formula here. So basically, I found that sine theta is negative 3/5, and then I found cosine theta, so it's opposite over hypotenuse. I said, well, this is opposite, negative 3. The hypotenuse is right here, negative 3 over 5, that's sine theta. And cosine theta, I said, was adjacent, so adjacent is right here over hypotenuse, so it's 4 over 5. So it's 4/5, right? So then I said, we can say, you know, sine of 2 theta, like I said, was 2 sine theta cosine theta. So then you go ahead and you say, well, it's 2 times, and we said sine theta was negative 3/5. We have 2 times negative 3/5, and then cosine theta. So this is, so right here is sine theta. Cosine theta is right here. Cosine theta is 4/5. Then I said 2 times, and then I said negative 3 times 4, that's negative 12. 5 times 5 is 25. So I said negative 12 times, or I'm sorry, 2 times negative 12 over 25. So then that gave me that sine of 2 theta is negative 24 over 25, okay? Now, the other one that I wanted to go over was, you know, how do we simplify cosine of 2 theta, right? And I'm also gonna, or actually, I will go over this one in a bit, but I want to do one that says, you know, simplify sine of 2 theta, right? This is, we already know it's 2 sine theta cosine theta, but again, you're wondering, well, how, right? You use what is called the addition angle, or I think the addition angle identity. So sine of x plus y equals sine of x cosine of y plus cosine of x sine of y, okay? And this is how this is how you kind of go about it. Now, as far as sine of 2 theta goes, we can say that this is the same thing as sine of theta plus theta, kind of like I did up here. I'm gonna do cosine of 2 theta in a little bit, but I want to make sure we understand why this, why it's equal to 2 sine theta cosine theta. So we're gonna do sine of theta, and like I said, this is gonna be this part, sine of theta, and then it's cosine of theta, so right here, and then plus cosine of theta, and that is right here, okay? So then this becomes sine of theta, cosine of theta, oops, and then plus sine of theta, because really cosine of theta sine theta is equal to sine theta cosine theta. That's like, if I say xy equals yx, right? That's the same idea. So we have sine theta cosine theta plus sine theta cosine theta. So this becomes 2 sine theta cosine of theta, okay? And that is why this identity holds true. So that means that sine of 2 theta equals 2 sine theta cosine of theta, right? Now what about cosine of 2 theta, right? We know that this is, I'm not really 100% sure how to prove this, but we know that this is true. We know that this is true for cosine of x plus y, right? Now, the way that you do this is you do the exact same thing. You're going to say cosine of theta minus sine of theta times sine of theta. Because that's theta, so theta is x and theta is y. So you're going to do cosine theta minus sine theta. So this simplifies as cosine squared theta minus sine squared theta. Here's the thing about this one, okay? This is not, so there's a Pythagorean identity that says sine theta, so sine squared theta plus cosine squared theta equals 1. You cannot confuse these two, okay? This one is equal to 1. This one is something else. We cannot say that this is equal to 1. This one actually has two different formulas. If we say cosine squared theta minus sine squared theta equals cosine of 2 theta, this means, so we have the Pythagorean identity. Sine squared theta plus cosine squared theta equals 1, right? We can solve, for example, we can solve this. We can solve it in terms of sine squared theta. If we do that, we get that cosine squared theta is going to be 1 minus sine squared theta, right? This ends up being 1 minus sine squared theta minus sine squared theta equals cosine of 2 theta. This is going to be equal to 1 minus sine squared theta minus sine squared theta equals cosine 2 theta. This is equal to 1 minus 2 sine squared theta equals cosine 2 theta, okay? That's one of them. The other one is, so we still have cosine squared theta minus sine squared theta, right? But instead of solving for, so we already solved for cosine squared theta and we plugged it in right here, right? We plugged it in right here. We're gonna do instead now we're gonna say, well, what is sine squared theta equal to? So if we solve for sine squared theta right here, we get that this sine, so we get sine squared theta equals 1 minus cosine squared theta, right? So now it's the other way around. So now we can say that this is cosine squared theta minus the quantity 1 minus cosine squared theta. This is sine squared theta, right? This we can then say cosine squared theta minus 1 plus cosine squared theta. This is really equal to cosine of 2 theta. Both of these are the same thing, but they're just in different terms. This one is in terms of sine theta. This one is going to be in terms of cosine theta. So really, this is equal to 2 cosine squared theta minus 1. So the main point of this little like mini lesson is that cosine of 2 theta equals 2, it equals two things. It equals 2 cosine squared theta minus 1, and it also equals 1 minus 2 sine squared theta. These are the two things that we must remember, and also cosine of 2 theta equals cosine squared theta minus sine squared theta. And you can simplify them using the Pythagorean identities. The Pythagorean identity that that sine squared theta plus cosine squared theta equals 1. So this can be simplified using, or can be not simplified, but found using, and also my handwriting is really crappy, but using Pythagorean identity. So it can be found using the Pythagorean identity, sine squared theta plus cosine squared theta equals 1. Okay. Let's see. Give me 1 second, guys. Give me 1 second, everybody. I'm going to try and look for more problems. So, what about, so now that we know how to find sine of 2 theta, or now that we found, or now that we know how to find cosine of 2 theta, right, we can use, that to our advantage. So again, if we have, so again, tan theta is negative 3/4, right? So we know that tan theta is negative 3/4. So what if we say find cosine of 2 theta, right? And so obviously we know from the previous example, sine of 2 theta was 2 sine theta cosine theta, right? Which was 2 times negative 3/5 times 4/5, right? And what about cosine of 2 theta, right? So cosine of 2 theta is, like we said it was cosine squared theta minus sine squared theta. Now for this part, you don't have to, what is it called? Like, you don't have to, oh, how do I say it? Like, you don't have to simplify it all the way like we did, unless it told you, like, you know, make sure you simplify cosine of 2 theta in terms of cosine theta or something. If it doesn't tell you that, you don't have to do it, right? We know from from the, from this right here, basically we know sine theta is -3/5, and cosine theta is 4/5. We know that, okay? The main idea here is we want to go ahead and say cosine of 2 theta equals, so cosine of theta is 4/5, right? Cosine squared theta is going to be cosine of theta quantity squared. And then sine squared theta is just minus, so it's going to be sine theta quantity squared. So then this is going to be 4/5 squared minus -3/5 squared, right? So then this will be 16/25 minus 9. Sorry, guys, give me 1 second. Okay, so this is 16/25, right? This is cosine squared theta, 16/25. And then minus, and then sine squared theta is negative, so it's going to be 9/25. This means that cosine of 2 theta is 16 minus 9 all over 25. This is going to be, this is really going to be 7/25. So cosine of 2 theta is 7/25, right? And that is how you do cosine of 2 theta. What about tan 2 theta? So tan of 2 theta, we can say this is equal to tan of theta plus theta. Now, for that one, and I have to look up the double angle formula for that one, because I really don't remember it off the top of my head. It's like tan, so it's going to be tan theta, so we know tan of x plus y. I only know the part, I think. Or I think I know the top one. It's like tan x plus tan y over 1 minus tan, I think it was like tan x tan y, I think. Yeah. So we want to do that same idea for tan 2 theta. We're going to say that tan of theta plus theta is tan theta plus tan theta over 1 minus tan theta times tan theta. This is equal to 2 tan theta over 1 minus tan squared theta. This is what tan of 2 theta is going to equal to. Okay? So then you ask, well, if we already have tan theta, because we have tan theta, we can just plug it in to find, so to find tan of 2 theta, we can plug in, for tan theta, we can just plug in, you know, whatever tan theta is, which is negative 3/4. So tan theta, or I'm sorry, tan of 2 theta is equal to 2 times, and again, tan theta is negative 3/4, so we're going to put negative 3/4 over, and then we're going to put 1 minus, and we're going to put, it's going to be tan squared theta, so it's going to be negative 3/4 squared. This is going to give us negative 6/4 over 1 minus 9/16, okay? If you want to know how to do this, so that at this point we just have to simplify. It's arithmetic, right? This is negative 6/4 over, it's going to be, we need the same denominator. We're going to have 16/16 minus 9/16. This is going to be negative 6/4 over 7/16. So then this is going to be negative 6/4 divided by 7/16, right? This is going to be negative 6/4 times 16/7. So then we know that this is, this one, we can simplify it or reduce it, right? This is going to be equal to negative, I think it's going to be negative 3/2. It's going to be times 16/7. This is going to be negative 48/14. And again, you're going to, I mean, you can, the way that you can also multiply this is by saying negative 3/2. And we know that 16 is 2 times 8. And then over 7. This is, it's like that. And then this is just going to be negative 24/7. So really, this is equal to negative 24/7 if you reduce it. So really, tan of 2 theta is negative 24/7. Okay? Okay, guys, and that is how you do double angle identities. That was one problem for double angle identities. I really hope that helped. If anybody has any questions about any of this, please let me know. If I made a mistake in any part, also let me know, because I am not perfect. I know even, any teacher can make any mistake, or any tutor can make any mistake. So please let me know if I messed up anywhere. But that is how you do, the double angled identities for, those are the 3 main double angle identities, and that is how you prove them, and that is how you simplify them using right triangle trig. So if anybody has any questions, please let me know. Please like, comment, and or subscribe, and hopefully maybe later I can do another quick live stream about how to do what is it called, half angle identities, which is the other kind, where you, instead of multiplying by 2, you divide by 2. So stay tuned for that. Thank you so much, guys, and I hope you have a wonderful day.